Hello everyone, this is Shrawan Sir, making maths simple for you. Welcome to my YouTube channel, Karna Maths Academy. In this video, we are going to discuss one of the most important problem, which is from the lesson Principle of Mathematical Induction. So dear students, in the previous video, already we have solved 5 questions and this is the 6th question of the solution of the principle of mathematical induction. Here we go. Dear students, the question is, using principle of mathematical induction, prove that n plus 3 whole square is greater than or equal to 2n plus 7. So dear students, in this problem, we are given a statement related to inequality, and by using the principle of mathematical induction, we have to prove that this relation is true. That means the value of n plus 3 whole square is always greater than or equal to 2n plus 7, where n is the natural number. Dear students, in the previous video already we have discussed related to the principle of mathematical induction. Dear students, in order to prove any statement using the principle of mathematical induction, at first we have to prove that the given statement is true for n equals 1. That means when we take the value of n 1, then the given statement must be true. Then secondly, we assume that the given statement is true for any natural number n equals to k. And thirdly, we show that the given statement is true for n equals to k plus 1 whenever it is true for n equals to k. That means whenever pk is true, then we prove that it is true for n equals to k plus 1. Then at last we write on the conclusion according to the basic principle of according to the principle of mathematical induction, the given statement is true for all the natural numbers n belongs to n. Here we go. Dear students, at first we have to suppose the given statement as Pn. The statement involving natural number is supposed as Pn. So let us suppose the given statement as Pn. Let Pn be the given statement. Let Pn be the given statement. Therefore, we can write Pn, that means the given statement, shows that n plus 3 whole square is greater than or equal to n plus 3 whole square is greater than or equal to 2n plus 7. Dear students, now the first step of principle of mathematical induction, or we can say according to the method of induction, the first step is we have to prove that this statement is true for n equals 1. So let us take when n equals 1. When n is equal to 1, distance when n equals to 1, that means we'll put the value of n1 on both sides, on the left hand expression as well as we'll put the value of n on the right hand expression, and we'll observe whether it is true for n equals 1 or not, because induction method is observation method, or we can say experimental method. So dear students, so let's put the value of n on the left hand expression as well as on the right hand side expression. When we put value of n1, then we get 1 plus 3 whole square. Again, let us put the value of n 1 on the right hand side. Then we get 2 times 1 plus 7. Let us do the calculation and let's observe whether it is true for n equals 1 or not. 1 plus 3 means 4. 4 whole square means we get 16. Greater than or equal to 2 ones are 2. 2 plus 7 we get 9. So this means we see that 16 is greater than 9. The number 16 is greater than 9. It means it is true. So dear students, the given statement is true for n equals to 1. So let's go in the further step. So dear students, let's write down the conclusion. In every step, we have to write down the conclusion. Dear students, we have got 16 greater than 9, which is true. So we can say that it shows that P1 is true. If we put n value 1, then our statement will be P1. It shows that P1 is true. That means the given statement is true for n equals 1. Dear students, now let's go to the second step of the principle of mathematical induction, or we can say induction method. The second step is, dear students, in the second step we assume that the given statement, that means Pn, the given statement is true for n equals k. Let us assume that or we can write, let us assume that Pn, that means our given statement, is true for n equals to k. Therefore, so dear students, we assume that the given statement is true for n equals k. So let's put the value of n k. So if we put the value of n k, then our statement will be pk, such that putting the value of nk, then it will be k plus 3 whole square, greater than or equal to 2k plus 7. So dear students, simply we have to put the value of nk in the given statement, then our statement will be pk, such that k plus 3 whole square is greater than or equal to 2k plus 7. So dear students, we assume that the given statement is true for n equals to k. So we have assumed that the statement is true for n equals to k. Now the next step is, if the given statement is true for n equals to k, then we show that the given statement is true for n equals to k plus 1. Now we show that Pn is true for n equals k plus 1 when pk is true. So dear students, this is the third step. By assuming that the given statement is true for n equals to k, we are going to prove that this statement is true for n equals k plus 1. So dear students, now we are going to show that the given statement is true for n equals to k plus 1. At first, let's write down the given statement, which is Pn such that the given statement is Pn such that n plus 3 whole square is greater than or equals to 2n plus 7. The given statement is Pn such that n plus 3 whole square is greater than or equal to 2n plus 7. So this is our given statement. So dear students, now we are going to show that the given statement is true for n equals to k plus 1. So I have copied the given statement, which is Pn such that n plus 3 whole square is greater than or equals to n plus 7. So let's put the value of n k plus 1. Let's put the value of n k plus 1. So if we put value of n k plus 1, putting the value of n k plus 1 in our given statement. So if we put value of n k plus 1, then it will be k plus 1 plus 3 whole square greater than or equal to n means k plus 1 plus 7. So dear students, when we take the value of n k plus 1, then our statement will be k plus 1 plus 3 whole square greater than or equal to 2 times k plus 1 plus 7. So now we are going to show that it is true by assuming that the given statement is true for n equals k. So dear students, already we have assumed that the given statement is true for n equals to k. So by using this statement, now we are going to show the given statement is true for n equals to k plus 1. So by 1, dear students, by 1 we are going to use that the given statement is true for n equals to k plus 1. So by 1 we can say by 1 we have k plus 3 whole square. We have k plus 3 whole square greater than or equal to 2k plus 7. So dear students, now by 1 already we know that the given statement is true for n equals to k. So we can write k plus 3 whole square equals 2k plus 7. So dear students, now in order to prove the statement is true for n equals to k plus 1, in the left hand side expression we have got k plus 1 plus 3 whole square. So the left hand expression, that means k plus 3 whole square, will change in the form of k plus 1 plus 3 whole square. So dear students, k plus 1 plus 3, that means it is k plus 4 whole square. So let's do some calculation in the rough. So this k plus 3 whole square, we are going to change in the form of k plus 4 whole square. So we know that k plus 4 whole square is, if we expand it by using a plus b whole square formula, then we get a square plus 2ab means 2 4s are 8k plus 16. So if we expand it by using a plus b whole square formula, then we get k square plus 8k plus 16. So this is now the expression of the left hand side we have to change in the form of k plus 4 whole square. So dear students, let's expand the expression of the left hand side at first. K plus 3 whole square means k square plus 3 to the 6k plus 3 square means 9. So by using the formula of a plus b whole square, we can write as k plus 3 whole square we can write as k square plus 6k plus 9. So let's keep the expression of the right hand side as it is. So dear students, so we have to change the expression k square plus 6k plus 9 in the form of k square plus 8k plus 16. So we have to do simply some manipulation. That means we have to make we have to change k square plus 6k plus 9 into k square plus 8k plus 16. So dear students, let's copy this expression k square plus 8k plus 16 on the right hand side. K square plus 6k k square plus 8k plus 16. So we have to convert k square plus 6k plus 9 into k square plus 8k plus 16. So simply we copy the statement k square plus 8k plus 16 on the right hand side, and then we'll balance with the expression with the above expression. We'll balance this expression with the above one. So dear students, let's balance it. So k square is already balanced. Now 6k and 8k, they are not balanced, so we have to subtract 8k from 6k. 6k minus 8k, that means we can write minus 2k. So simply we have to do some adjustment. So dear students, 8k and 6k, they are not balanced, so difference between 6k and 8k is minus 2k. That means 8k is 2k more than 6k, so we have to subtract minus 2k. So let's balance now 9 and 16. 9 minus 16, we get minus 7. So dear students, if we add minus 2k and minus 7, these two terms, then both the expression will be equal with each other. So always we have to make balance with the above, with the previous expression, or we can say statement. Dear students, now the left hand expression of both these steps are balanced with each other. K square and k square, they are balanced. Now 8k minus 2k will get 6k, so it is also balanced. 16 minus 7, it is also equal to 9. So we have to balance. So dear students, let's keep the expression of the right hand side as it is. So keeping 2k plus 7 as it is. So dear students, now k square plus 8k plus 16. K square plus 8k plus 16 we can write as k plus 4 whole square. This is equal to k plus 4 whole square. 3 plus 1 means 4, k plus 4 is k plus 4 whole square. So dear students, k square plus 8k plus 16 we can write as k plus 4 whole square, which we need according to the left hand expression of k plus 1th term. On the left hand side we need k plus 4 whole square. So now we have got k plus 4 whole square on the right hand side. So dear students, now the remaining two terms, that means now minus 2k and minus 7 will shift to the right hand side. So dear students, 2k plus 7 keeping as it is, and minus 2k minus 7, we are going to move on the right hand side. Then it will be minus 2k will be plus 2k and minus 7 will be equals to plus 7. Simply we have moved the remaining two terms from the left side to the right side, from left hand side to the right hand side. So dear students, let's do now the expression of the left hand side already we have got. Now we are going to change the expression of the right hand side same as the expression of the right hand side of k plus 1 term, because we need to prove k plus 4 whole square is greater than or equal to 2 times k plus 1 plus 7. So dear students, now we are going to simplify the expression of the right hand side, and we are going to change it in the form of 2 times k plus 1 plus 7. So this is, the process is very simple. We have to do some manipulation. So whatever we need, that means if we need 2 times k plus 1 plus 7, then the same thing we copy over here. So let's copy this expression. So dear students, in order to get the expression 2 times k plus 1 plus 7 on the right hand side, we don't look what we have. We just focus what we need. So dear students, we need 2 times k plus 1 plus 7. So simply we copy the expression of the right hand side and we write over here. Then we'll balance. Dear students, mathematics is nothing. It's simply just like a game. So if you enjoy playing game with maths, with formula, then you can easily solve any kind of problem. So dear students, I have simply copied 2 times k plus 1 plus 7 over here because I need this expression. I don't look what I have. I just focus what I need. So I have copied 2 times k plus 1 plus 7 over here. Now dear students, now let's balance. Let's balance all these terms with the above one. So 2 times k already we have got. So the first term is balanced. Now 2 ones are 2 and plus 7. 2 plus 7 will be 9. But in the previous step we have got 7 plus 7 14. So we have got 9 but we have balanced with 14. That means 7 plus 7 14. 14 minus 9 we get 5. So this means if we write on plus 5 over here, then the constant terms will be balanced. Let's check it. 2 times 1 we get 2. 2 plus 5 7. 7 plus 7 14. And in the previous step, in the previous statement expression, the value of constant is 7 plus 7 14. So 14 is balanced with 14. So constant terms are balanced. Now let's look at the remaining terms. The remaining term is 2k. So this is the extra term. So this will write as it is. So this is, now if we compare all these terms with the previous step, with the terms of the previous one, then all the terms are exactly balanced with each other. Let's check one time more. 2k is balanced with this term. 2 ones are 2. 2 plus 7 9. 9 plus 5 14, which is balanced with 7 plus 7 14. And the remaining term 2k we have just copied. So this means all these terms are balanced with the previous one, the terms of the previous one. So we have written equal sign over here. So this means now what we need, we focus on what we need. So again we are going to write down this expression only over here, because we have to prove that k plus 4 whole square is greater than or equal to 2 times k plus 1 plus 7. The expression of the left hand side already we have got. Now simply we are going to manage to find out the expression of the right hand side. So again I will just I'll just damn care what I have. I'll just focus what I need. So this means it is called manipulation. Such type of steps is known as manipulation in mathematics. What we need, we just focus on that, and accordingly we balance everything. So dear students, so I'm going to copy this expression 2 times k plus 1 plus 7. Now I need the relation greater than or equal to. So I can write here the relation greater than or equal to. So dear students, now I also need the relation greater than or equal to between these two expressions. So I'm going to copy now this relation. greater than or equal to 2 times k plus 1 plus 7. Simply I have copied this one over here. So this is, let's compare now whether we are eligible, whether we can write this or not. So this is 2 times k plus 1 plus 7. Let's compare again. 2 times k plus 1 plus 7, 2 times k plus 1 plus 7. It is balanced. And we have got two extra terms, which is 5 plus 2k. So this means now this whole expression, in this expression, so this means this expression contains all the terms of this one, that means 2 times k plus 1 plus 7 we have got over here also. So simply we have taken sum of the part of this whole expression. This is only 2 times k plus 1 plus 7 is only sum of the parts of this whole expression. So this means any whole object is always greater than or equal to sum of its parts, or we can say the whole object is always greater than its components. Like our two hands is greater than or equal to, is greater than our whole body. So dear students, the whole part is always greater than or equal to its components. So we can write this statement. It is obvious in mathematics. So dear students, finally we have got k plus 4 whole square greater than or equal to 2 times k plus 1 plus 7. So we can say now the given statement is true for, dear students, now we can say that it shows that, so let's write on the conclusion now. It shows that pk plus 1 is true. It shows that pk plus 1 is true when pk is true. By assuming that pk is true, so dear students, we have proved that when the statement pk is true, that means when the given statement is true for n equals k, then we have proved that the given statement is also true for n equals to k plus 1. Hence, by the principle of mathematical induction, hence by the we have to write on the final conclusion now. Hence, by the principle of mathematical induction, the given statement is true for all the natural numbers and Pn is true for Pn is true for all n belongs to n. N is natural number and capital N is the set of natural numbers. So this means we have proved that the given statement is true for all the natural numbers and belongs to n. So this means dear students, I hope that you have understood how to prove the problems related to natural numbers by using the principle of mathematical induction. Next time we'll meet with a new content. Till then, bye. Have a nice day. Thank you.